Hello, today I'm going to be going over the process to do the Condenser's Auto Service AC performance test. Doesn't matter what type of vehicle you're working on, the components of the AC system are all basically the same. It's one of the systems that I've seen with newer technicians where they would have the most apprehension because they don't understand how it works. So just a quick overview of the components. I'll flip this guy around here. Your main component is going to be the compressor that's down there, and a lot of times I'll look just physically to make sure that the front of the clutch is still on there and the belt is connected. You'd be amazed at how many people come in and those parts are missing. Other components would be up front in front of the radiator. Down there is the condenser. You're going to have your hoses, your high pressure and your low pressure coming off of the compressor. They're going to follow through to the evaporator core. Sometimes you'll have an accumulator or dryer in the middle of that on the outside. Sometimes you won't have it on the outside. It'll be part of the condenser. Okay, so the first thing I'm going to do in this step is figure out what kind of refrigerant this car has. Now that we're dealing with a new generation of refrigerant, you've got three possible refrigerants that we could have going on. If it's a vehicle prior to 1994, it's probably R12. There is a possibility that the R12 has been changed over to the R134A. Hopefully so, because none of our shops, I don't believe, have an R12 machine anymore. So if it's been converted to 134, then we're fine. Now there's a new one that came out, I believe in 2017, and that's the R1234A. And that's in the newer vehicles. We're starting to see them here. So we've got the equipment for those now if we can service them. So first thing I'm going to do is find the identification sticker and look at the service ports. So I see here that it does have the R134A service ports. You locate those in the engine compartment, and that's what they look like there. That's the high side port. And then I'm going to find the sticker that identifies it and tells me my capacities, and I found that, and that's right here. A little dirty, but so it is an R134 system in a full charge here. The machine, you can tell it kilograms or pounds or ounces. So I like pounds. It's 1.38 pounds. And it does say that the system came from the factory with dye in it already. So those two things are helpful. So to protect our equipment and make sure we're servicing it safely, there's two steps you do before you hook up the AC machine. One is the refrigerant identifier. The reason for the refrigerant identifier is to make sure we're not dealing with any combustible gases or a mixture of R12, R22, or R134. A lot of times somebody will have a friend that works in refrigeration for commercial applications, and they'll charge it with R22 to try and help out their friend. Or they'll find a shop that still has R12 laying around, which is rare nowadays, but back when they changed this over in the mid-90s, it was kind of common, and they'd figure out a way to adapt it to an R134 system. So this just identifies what's in the system before we get going. The main thing to remember here is if it does show up with hydrocarbons detected, that means it's a flammable gas. A lot of times if you go over the border down south, they'll charge it with propane. You do not want to work on that vehicle. That is a hazard, and you should stop at that point. The other thing we do before we hook up to the machine is the sealant detector to make sure that they haven't pumped it full of refrigerant sealant trying to fix a leak instead of repairing the leak. So those two items can be found, the procedures for them, are found in the instruction manual on each one. I've jumped this step just for time's sake for this video, and we'll go into the actual performance test, assuming that it passed these first two preliminary tests. So to protect our equipment and make sure we're servicing it safely, there's two steps you do before you hook up the AC machine. One is the refrigerant identifier. The reason for the refrigerant identifier is to make sure we're not dealing with any combustible gases or a mixture of R12, R22, or R134. A lot of times somebody will have a friend that works in refrigeration for commercial applications, and they'll charge it with R22 to try and help out their friend. Or they'll find a shop that still has R12 laying around, which is rare nowadays, but back when they changed this over in the mid-90s, it was kind of common, and they'd figure out a way to adapt it to an R134 system. So this just identifies what's in the system before we get going. The main thing to remember here is if it does show up with hydrocarbons detected, that means it's a flammable gas. A lot of times if you go over the border down south, they'll charge it with propane. You do not want to work on that vehicle. That is a hazard, and you should stop at that point. The other thing we do before we hook up to the machine is the sealant detector, to make sure that they haven't pumped it full of refrigerant sealant trying to fix a leak instead of repairing the leak. So those two items can be found, the procedures for them, are found in the instruction manual on each one. I've jumped this step just for time's sake for this video, and we'll go into the actual performance test, assuming that it passed these first two preliminary tests. So before I hook a machine to the car, what I'm going to do is start it up. I'm going to put the AC system in recirculation mode. Make sure the compressor's on. I'm going to set it to the coldest setting. I'm going to turn the fan on high. Then I'm going to take my thermometer, I'm going to turn it on, and I'm going to stick it in the center vent. That's where I want to grab my reading from. I'll let it kind of normalize here. It's a pretty hot day out here, so right now my ambient temp reading, well, it's pretty hot. I'm going to say it's just around 100. We're going to put it in the center vent, and then I'll record this temperature reading on the work order once it normalizes. It's actually going up. That's a bad sign for an air conditioner. So we'll wait till that normalizes, and we will record that on our before service readings. I'll also record what the ambient temperature reading was. That way we can get a baseline reading on both the AC and the external temperature. As you can see, this is climbing up north of 120. That AC system is not doing anything. It's actually making the air hotter than it is outside. So at this point, I'm gonna leave the vehicle running, and I'm gonna go outside and hook up the machine, and I'll jump to that in the next video. Okay, so I've got the machine plugged in, and before I hook it to the car, I make sure that both of my gauges are in a vacuum mode. That means the person who used the machine last did not leave a charge in the hoses. If you get to the machine and these gauges have positive pressure, you don't hook it to the car you're working on until you recover the machine. That way we don't accidentally charge it as soon as we hook up the machine with some refrigerant. So I verified that it's in a vacuum. I'm going to locate my service ports and take my two hoses, the red being the high side and the blue being the low side, and hook them to my ports. This particular car has the high side port here. Here's the cap. I'll take the red hose, which is the high side hose, flip it on, pulling this collar back, slide on the hose, and then when you turn this screw, that opens up the Schrader valve that's under there and allows the refrigerator to close it up. Now I'll go over and I'll check my high side hose. Usually you would see this pressure jump up. It's moved a little bit, it's off a vacuum, but it hasn't really jumped up much. My guess is there's nothing in this system. I'm going to locate the low side port, which is right here. Take off the safety cap. Route the blue hose, which is the low side hose, around the running engine so it's not going to interfere with anything moving. Again, we pull back the collar, clip it securely on, and then screw the cap to access the Schrader valve. I'll come over and look at my pressure. Now I see it's gone up a little bit, so we're not in a vacuum anymore, but there's very little pressure. Typically you'll see the readings much higher than this on your initial inspection. So I will again notate these pressures on the before service readings for the high and the low pressure on my work order. Now what I'm going to do is I'm going to shut the engine off and we'll start the recovery process. Okay, so I've shut the engine off. Now we're going to start the recovery process. I've noted down in AS1 what my before service readings were for the ambient temperature, the vent temperature, the high side pressure reading, and the low side pressure reading. I'll come over to my menu here, and over on the right side I'm going to hit recover. It's going to ask me if I want to change the oil. It's only got 10 hours on it, so no, I'm not going to change the oil. Do I want to fill the tank? Nope. Select function, recover. It's going to check the pressures. It says low recover pressure, check connections, recover anyway. Yes, I know my connections are good, I just know the system's low. So I'm going to hit yes, and it says recover in process and it's clearing. So I'm going to let the machine do its work and then I'll get back to the next step. Okay, so the machine has finished its recovery process. Recovery complete. recovered 0.06 pounds. Going back to identification sticker from the beginning, a full charge is 1.38. So in essence, this vehicle is empty, which we kind of figured. So my next step is I'm going to pull a vacuum on the system. So I hit vacuum. I go through my prompts again. Do I want to change the pump oil? Nope. Do I want to fill the tank? Nope. Select my function, vacuum again, change the oil? Nope. It's checking pressures. So I can enter in a different vacuum time here if I want. I've got 10 minutes entered here. I'm okay with that to start with. I might do longer. Once I'm going to do a final charge, I might pull it down for a half hour to make sure I get all the moisture and air pockets out of the system. But for the testing, I'm going to do 10 minutes. It says enter a new timer, start to continue. So I'm good with that. I'm going to hit start. Do I want to do a leak test, that's asking me. For this process, yes, I would like to see a leak test to make sure it holds that vacuum. I'm going to start it, and you'll see that counter count down, and we'll get back to it after it has gone through its process. We're okay to walk away from the machine at this point. So the machine's still currently doing the vacuum test. What I wanted to point out is I'll do a visual inspection of the AC hoses. I'm kind of shining my light on them. What I'm looking for is any kind of accumulation of dust, dirt, or oil. Because there is oil mixed in with the refrigerant and the dye, it will leave a residue behind if it leaks. I'm looking at the connections where they go into the firewall there. I don't see any residue. I'm going to trace them all the way back to the condenser where they connect. And I'll look at the hoses themselves, and then lastly the compressor. See if I can see any physical leaks going on. Now they do have something going on over here by the water pump, so it's hard to tell because the compressor's kind of wet from that. I don't see anything obvious as far as the AC goes. But it's kind of funny with AC, you got to use all your senses. You got to use your sight, checking it visually. You got to use your smell, because you can actually smell refrigerant leaking when you hit recharge and it's got a pretty significant leak. You'll smell it. And you can also hear it, so you can use your hearing as well. I guess taste. I don't usually use my taste, but I use the other senses. So just a once over to see if I see anything obvious as it's going through its leak process. The hoses are typically made up, like this one here, of metal. It's usually aluminum, and then rubber. You'll see a lot of times the hose itself, the rubber portion of the hose will get a leak because of abrasions, or at the connection where the aluminum and the rubber are crimped together right there. You can see a lot of leaks a lot of times. The other places you see is at these ports here where there's a joint, there's going to be a rubber seal, and that's usually a high failure rate area as well. And we have seen a lot of times where that metal tube is being rubbed on by a power steering hose or a metal bracket that's supposed to help it, but has actually come loose and it's rubbed a hole through the metal. So a quick once overview of all these common areas. I don't see anything jumping out at me. Can shorten up the diagnostic process when you're trying to find a leak. Another good place to check for leaks when you're waiting for the machine to finish on the vacuum part of it is at the condenser. And that's up in front behind the grill. This is a pretty bad example as far as the grill goes because it's hard to see in there, but I'm going to shine a light in there, look at all the fins, all the tubes. The reason this is so common is you get rocks and debris coming up from the road. I've seen birds stuck in there. There's a hit right there, and that might have gotten a tube. I don't know if you can see that in the light there, but there's a ding right there. So I'll be sure to check that once I put some dye in it. It looks like it might actually be split there. Look around here and see if there's any obvious damage, and that'll shorten up your diagnostic process once again. Again, this isn't the most complicated system in the world, but a lot of people get, I guess, trepidation from working on it just because they don't know the functionality of all the components. I think I touched on it earlier, but again, so the refrigerant's in a fluid form right now. It's under low pressure. When it gets under a high pressure, it turns into a gas. The compressor moves it around. So the compressor makes it a high pressure gas, pushes it through the smaller hose, which is your high pressure hose. This is also called the discharge hose. That'll flow out to your condenser where it will cool it down. It's got air running over it just like a radiator. That's going to cool it down into a very cold but still high pressure liquid. From there, it's going to run back to the evaporator core. At some point, it's going to run through a dryer where it's going to take out, it's going to filter out any particles, and it's also going to take any moisture out of it, because if moisture goes through that expansion valve, it can freeze it up. So after it goes through the expansion valve, which limits the flow of the refrigerant, it's going to go through your evaporator core. Evaporator core that's inside the heater case under the dash, and that's what has the blower motor blowing on it, and that's how you get the cold air in the cabin. The air pushes the air over the the fan pushes the air through the evaporator core. The cold air comes out the other side, goes through the vents and into the passenger compartment. Once it goes through the evaporator core, your refrigerant is now on the suction side, and it gets sucked back into the compressor. The process starts all over again. So it goes from a high pressure gas, turns into a very cold high pressure liquid, gets shot through there as a low pressure very cold liquid, and then turns back into a gas as it comes out, gets sucked back in the compressor, gets compressed again. So it just keeps moving and cycling, getting high pressure, low pressure over and over again. All right, so now we've gone into the leak test portion of this. Backing up a little bit, the reason why we pull a vacuum down once we've recovered and measured how much refrigerant is in the system is to remove any impurities that got in there. If there's a leak, outside air can be pulled into the system. We don't want any air pockets, we don't want any moisture in there. So the vacuum will pull out all the atmospheric air, it'll pull out all the moisture, and then it's going to leak test it for us. So if we've got 29 inches of mercury or more, and it'll hold for a half hour, then we're okay to charge it up. So right now it's running through its leak test, and what the machine's doing is monitoring the amount of vacuum that the system's holding to make sure we don't have a large leak and that we can recharge it safely and legally. So we're through with that vacuum portion. It's doing the leak test now. I'll jump back once that portion's done. Okay, so after the leak test, now I'm going to replace the Schrader valves. Here's a picture of the old ones. That's your high side, that's your low side Schrader valve, just like in a tire. There's a tool to take out that one, obviously. And then this one, you just grab it right about here with a pair of pliers, and then use another pair to hold the base of the line so it doesn't twist, and then remove it. I'm going to install new ones here. I put just a drop of PAG oil on both of the O-rings, the orange one on the low side and that black O-ring right there on the high side fitting, just so they don't tear when I'm installing them. So the high side one goes in here. I'll tighten that down with pliers. And the low side one down in the low side hose. Install that with the valve stem tool. It's just finger tight. You don't want to muscle it in there. It doesn't need to be that. Just a nice snug with your thumb and forefinger. I'll tighten this guy down, and then I'm going to do a real quick vacuum so I can install the die. Okay, I got both my Schrader valves in. So my menu says vacuum completed, leak test passed, any key exits. So I can hit any key. Do I want to change the oil? No. Select my function vacuum. Change the oil, tell it no again. It's checking pressures. I'm just going to do a real quick 1 minute vacuum. I'm not going to do a leak test because I already know it passed. This is just to give me enough vacuum to pull the UV dye into the system. So on the UV dye, I'm trying to do this so you can see, graduated lines here. I'm going to put an ounce in it. And the way I do that is just I turn this portion up an ounce. Fairly easy. I just can't do it real great with one hand, so I'm going to show you here. I'll go up. Get to an ounce. And then once this is done, it's just about done now, I will disconnect the low side hose down there, and I'll hook this fitting up to where the machine was connected, and that'll pull the dye into the system. So then I'll have a green ultraviolet dye flowing through the AC system to help me visually check for leaks with the ultraviolet light. So the machine is done. I'll go ahead and unscrew the actuator before I disconnect the hose. Pull up on the collar, disconnecting the hose. I've got the dye injector. I'll connect it, pull up the collar. Once I pull up the collar and push down, you'll feel it connect. You can actually hear it when it's done. It'll pull the dye in. You can feel it running through the hose. It's done. I'll disconnect it. You can see a little remnant of the green dye there. Reconnect my machine up. Put it on there. I'll pull up the collar. Screw down the actuator wheel. Oop, I didn't get the collar all the way on. Sometimes that happens, so we unscrew it. Pull up on the collar again. Wiggle it on there, make sure it's locked. Pull up on it. If it doesn't come off, then you're good. Screw on the actuator wheel. Back to my machine. So now we're ready to charge. Referencing back to my ID sticker, 1.38 is a full charge. So it says vacuum complete any key. So we'll get back to my charge screen. So my charge, it's already set for pounds. So I'm gonna do 0, 1, 3, 8. Now my mode, it says high side charge, or I'm sorry, its mode is high side. It says charge changes mode, arrows changes the units. So if I wanted to go with my arrows, it'll change it to grams, it'll change it to ounces, it'll change it to kilograms. Right now I'm on pounds, that's where I want to be. So charge changes the mode. So if I hit the charge button, it changes it from a high side to a low side charge. I usually charge to the low side. The reason being, that's the suction side. If I've got a system that's not accepting the refrigerant, it's taking a really long time, I can always start up the car and pull it in through the low side, or I cannot do that to the high side. So I've got my charge set to 1.38 pounds. I've got my mode set to low side. I'm gonna go ahead and start the charge. And what I'm gonna do once I hit this start button is I'm gonna listen under the hood. I'm gonna listen for any kind of leak. I know it came in with no refrigerant, so I'm trying to figure out where it's going. So like I said, I'm gonna use my smell, I'm gonna use my ears, I'm gonna use my eyes, and I'm gonna try and figure out if I can see a leak. If I see one, I'll run back to the machine and I'll hit the stop button, and then I'll start the recovery process to pull the refrigerant out if I see where the leak is. If I don't, then I'm gonna start the vehicle up, let it run for a while, let it circulate that green ultraviolet dye, and then I'll shoot it with the UV light to see if I can see a leak. So right now we're good to go. I'm gonna hit the start button. It says charge and process, do not disturb. And the main reason it's telling you don't disturb, you don't want to shake the machine at this point because the refrigerant is being weighed inside. If you're rocking the machine around and that tank is on a scale, you're going to change the weight. So it's a very accurate scale that gets recalibrated every once in a while. So you want to make sure you're not jarring the machine around, bumping into it, because you might get a false charge out of that. So it's charging away. It's already up to a pound. And then I'm looking underneath here and I'm listening. I'm seeing if I see anything leaking. You can see a little cloud sometimes if the refrigerant's coming out fast enough. I'm checking the hoses. Right now I don't see anything, so we'll jump forward in the next step. Okay, so my message is complete. Charged to 1.38. I'm looking at my pressure gauges. I see that we do have pressure reading on both. Sometimes if you have a block system, you'll notice that the pressures will be a little off. I've got about 125 on both. So I'm gonna go start up the vehicle. I've got my thermometer in the center port again. I'll make sure it's on max cold, on recirculate, in the highest fan setting, and we'll see what's going on. Let's see what we get down to now. Well, we're dropping down from 120 that we were at before, so that's already a good thing. I'm looking out the windshield at my readings on my gauges, and they look a little high, but it is over 100 degrees today, so you're going to get higher static readings automatically. Air coming out of the vents is much cooler than before. I don't know that I would say it's super cold, but it's definitely cooler. Going the right direction. So it's a little bit over 100 degrees outside today. I'm already dropping down into the 70s. I know that doesn't sound cold, but the temperature differential feels great inside. My goal, I'd like to see it hit 50 degrees coming out of the vents. If I could get a 50 degree temperature differential, that system is working super efficient. Most of the time though, sitting at idle, you're gonna find somewhere around a 40 to 45 degree temperature differential with the ambient to your vent temp. And that's pretty good for a newer car. Let's go out and look and see what our pressure readings are at our machine. So I'm notating down my ambient temp. I'm notating down my vent temp on my after service readings. And then I'm also gonna notate down what these pressures are. So my low side pressure is right about 35. My high side pressure is right about 240 PSI. So I'll notate those down. And then once again, I'll grab a flashlight as the vehicle's running here. We'll look around for anything obvious. See, the compressor's obviously engaged. Since we've got pressure, we know that that's happening. I'm gonna see if I see any drips. I see my cooling fans operating. All right, so we're gonna revisit the vent and ambient temps. I've got an ambient temp of just about 101 here. We'll put it in the center vent. See how we did on our recharge. See what we dropped down to. Remember, I'm shooting for a goal of about 50 degrees difference from our ambient temp to our vent temp. She's dropping down pretty good. These are the numbers I'll put on my after service for my final numbers, along with those pressures from the AC machine. So if I've got an outside of 101 and I'm under 51, I am doing pretty good. This system is working pretty efficiently. I'm getting down into the high 40s. So once it normalizes, I'll record that reading, put that in my auto serve 1 notes under the after service readings, notate that for the client, and then I'll show you what to do in the next step here with the AC machine, with the car running once we're done with our service. Okay, so I've notated down all my pressures and temperatures. Now my message on my machine says, charge to 1.38 pounds, press start to equalize hoses, stop to exit. So I don't want to leave the machine with the charge on the gauges for the next technician to come in. So I'm going to press start. It says connect low side hose, start AC max, and then hit start to continue. So I'm going to come over, I'm going to disconnect my high side hose. Leave my low side hose connected. Get a little pop out of that high side when it comes off because that's a higher pressure. Go inside and start the vehicle. Walk back out to the machine. I'm gonna press the start button. You'll see it go through its process, equalizing the pressures. And it's pulling anything that should have been charged in the car through the low side right now. That's why you've still got the low side hose connected to make sure we get that whole charge into the vehicle. So now my next message is disconnect low side hose, start to continue. So I'll go down here, unscrew my port, pull up on the collar, we're disconnected. Both hoses are off the vehicle. Wrap them around my machine here. I'll hit start. And now it's clearing the hoses is the message. What that'll do is that'll put both of these gauges in a vacuum. You won't have any refrigerant left in the lines for the next technician. This takes a minute or two. Once it's done, then you can power off the machine and it's safe to store. And it's ready for the next technician. Don't leave a charge on the machine for the next guy to have to clear it before he starts his job. You're not gonna make a lot of friends that way.